we use the Big Ideas math textbook and follow that for most of these classes. Some of the topics, though, I use a couple of other textbooks. Anyway, the very first topic in polynomial functions is given a polynomial. How do you graph the polynomial function? How do you understand how many roots are there in the polynomial function? And what is the end behavior of the polynomial? I'm not sure if you've been exposed to some of these terms before, so let me very quickly go over the meaning of different terms that I just used. First of all, what is a polynomial? A polynomial, as the name suggests, is basically a group of monomials together, wherein each of the monomials will have the x term or the variable term raised to a certain power. All right. So a polynomial function is generally in the form of a constant x power n plus another constant x power n+1 plus another constant times x power n+2, so on until constant times x plus ending with a constant. So the constant that accompanies the x term with the highest power, for example, if I tell you x power 4, 2x power 4 plus 3x cube plus x square plus 1. Let's say this is a polynomial, right? So I have different monomials wherein x is raised to different powers. Here, the constant or the coefficient that accompanies the x term with the highest power, which in this case is x power 4, is called the leading coefficient. The highest power that the variable of the polynomial is raised to is called the order of the polynomial. Okay, or the degree of the polynomial or the order of the polynomial. And the last term here, this one, is actually called a naught. This is the constant term of the polynomial. Does that make sense? So since your mic is not working, in case you have any doubts or you want me to go slower, faster, stop and explain something, just type it out in the chat box, all right? Okay. All right, so this is about different terms in the polynomial. Now, the next thing is, let's look at some common polynomial functions. If the degree is 0, if the highest power that the variable is raised to is 0, then all you're going to have is one constant, correct? Then f of x equals a naught is how the function would look like, and that is called a constant function. If the degree is 1, then f of x will be equal to a1x plus a naught. Then it's a linear function or a function that whose graph is going to be a straight line. If the degree is 2, that is, if the highest power is raised, highest power of the variable is raised to 2, then it's going to be a quadratic function. a2x squared plus a1x plus a naught is an example. If the degree is 3, then it's a cubic function. If the degree is 4, then it's a quartic function. So these are different kinds of polynomial that you see that are basically distinguished on the basis of their order or degree of the polynomial. Now let's look at example 1. Look at parts A, B, C, D. Identify whether each function is a polynomial. If yes, write it in the standard form. So what do you mean by standard form? Standard forms means the terms are written in the decreasing order of the powers to which the variables are raised, a decreasing order of the exponents. For example, if you see the quadratic function here, x power 2, then x power 1, and then x power 0, right? So that is the standard form. So go ahead, identify whether each of these functions are polynomials or not, and then write it in the standard form, state the degree, type, and leading coefficient. Can you try this out? Okay, all right. So let me show you how to do it with the first question. So A is, yes, it's a polynomial function. That's correct. How do you order them? You have to see whether the terms are written in the descending order of the exponent of x, right? So in this case, you have x cube here, and then you have x, and then you have a constant. So it is already in a descending order, correct? So the function is already in the standard form. Does that make sense? All right, can you try out question B? And yeah, before that, what type of polynomial is this? This is a cubic polynomial. The leading coefficient is -2, right? And the degree of the polynomial is 3. Now try out part B. Very good. Yes. So the degree of the polynomial here is 4. The leading coefficient is square root of 2. And what you've written is the standard form. Excellent. Can you try part C? Hey Tej, is it possible for you to get your mic to work by any chance? Maybe connect to a different audio source or something. All right. Yeah, please do.
Hello? Hello?
Hello?
Yeah, can you hear me?
Very feeble. Let me increase my speaker volume. Can you speak now?
Hello?
Yes, much better. Okay, yeah. Our life is going to be much simpler from now on. You don't have to type out every equation. All right. So yeah, part C. Can you tell me if it's a polynomial? And yeah, go ahead.
Uh, I don't think it's a polynomial, is it? Because the square root of -1.
That's correct. So it's not a polynomial. All right. Part
Yeah.
D.
It would be x. Actually, no, it wouldn't be a polynomial because it's 3 to the power of x.
Perfect. All right. Oh, this is great. I don't feel like I'm speaking to a screen anymore. All right. So this is okay. Now, evaluating a polynomial function. If someone tells you, can you evaluate this polynomial at x equal to some value? All you need to do is substitute that value for x in the function and tell what the polynomial evaluates to. You try out
Okay.
example 2.
Uh, which for example?
Here.
Okay, yeah.
Let me know if you're stuck somewhere.
Yeah. Is it 98?
Yeah, that's correct.
Okay.
All right, so that's about introduction to polynomials. Now let's learn a little bit about graphing a polynomial. So the first thing we'll learn about is called the end behavior of the polynomial function. The end behavior essentially means when x becomes a really large value or a really small value. For example, if x is approaching something like a positive infinity value, or if x is approaching a negative infinity value, then how
Okay.
does the polynomial itself behave? This is what is known as the end behavior. Now, there's a very nice little quadrant here to summarize the end behavior of polynomial function. So if you have an odd degree and the leading coefficient is positive, so I hope you now understand what these two terms mean, right? So if
Yeah.
you have an odd degree and if the leading coefficient is positive, then as x approaches positive infinity, your f of x, so the function itself, will also approach positive infinity. And as x approaches negative infinity, your f of x will also approach negative infinity.
Okay.
If the degree is odd and the leading coefficient is negative, then the graph is flipped. So as x approaches negative infinity, f of x approaches positive infinity. And as f of x approaches positive infinity, f of x approaches negative infinity.
Okay.
Next, when the degree is even and the leading coefficient is positive, then your graph looks something like a lowercase w,
Okay.
wherein as x approaches infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x still approaches positive infinity.
Okay.
When the leading coefficient is negative and the degree is even, the graph gets flipped with respect to your x-axis. So it'll be a mirror image, a W that is facing downwards. So you
Okay.
can make a note of this or take a snapshot, however it works for you. Okay, it'll
Yeah.
turn out to be really useful.
Yeah, I did it. I took a screenshot.
Okay, great. Okay, now example 3, you've been given a function. Can you describe the end behavior?
Uh, would it be so f of x equals x? Would it be negative,
Yeah,
odd negative?
it's even negative, right? What's the degree of the polynomial here? 4.
Or oh, okay.
Okay, so these are the only two things that you need to look at. What's the degree? What's the leading coefficient? So the
Okay.
degree is even. Leading coefficient is negative 0.5, and therefore your end behavior is going to be like this, right? An
Okay.
inverted
Yeah.
W. All right. So can you try one more question? Try out question number 6.
Uh, odd positive.
That's
Wait,
correct.
no. So okay. Yeah.
Yeah.
So you just look at the leading coefficient, right?
Yeah, leading coefficient
Okay.
and the degree.
Okay.
Okay. Does that make sense?
Yeah.
All right. Now let's look at how do you go ahead and graph polynomial functions. So when you're given a polynomial function, for example, let me take example for part A. What I'll do is I'll take a bunch of values of x, okay? Some of them on the negative x-axis, some of them on the positive x-axis, and then I'll
Okay.
make a table. Now in the table, what I'm going to do is for each value of x that I've taken, I will substitute that into the polynomial function and figure out what does the polynomial evaluate to. Now, once I
Okay.
have all of these points, right, I put them on a graph and I connect them with a smooth curve. So that approximately tells me how the polynomial is going to look like when it's graphed. Now, with this, from the leading coefficient and the degree of the polynomial, I'll also be able to figure out the end behavior of this graph, right? From
Yeah.
what I taught you just before
Yeah.
this. So I use that concept and I draw the end behavior of this polynomial as well. For example, in this case, um, you have a negative leading coefficient and the order is odd, which is 3. And therefore, your polynomial end behavior is going to be like this. X tends to infinity, x tends to negative infinity, f of x tends to positive infinity, and x tends to positive infinity, f of x tends to negative infinity. And we've taken a
Okay.
bunch of values of x from -2 to 2, evaluated f of x, plotted those points, and joined those points with a smooth curve. Okay?
Okay.
Now, can you go ahead and try part B and try to graph this using the same technique?